Hi friends, welcome. In this session we study about the Duncan's test. In statistics, the Duncan's new multiple range test MRT is a multiple comparison procedure developed by David B. Duncan in 1955. Duncan's MRT belongs to the general class of multiple comparison procedure that use the studentized range statistic QR to compare sets of means. Here I would like to explain more about the Duncan's test. Here you see the procedure how we get the Duncan test. Here I have written some formula here in this table. Here you see AC into RP into square root of 1 over n, where AC is the standard error which would be calculated through this formula. It is the square root of summation of S's over k into n minus 1. And SS is equal to summation of x square minus summation of x whole square over n. Here I explain you the contents what we are taking here. K is the number of groups what we are taking. N is the number of observation of each group. RP is the least significant standardized range, or RP is value of significance level 1% or 5% for Duncan test, range test. So Duncan range test I will explain it with a tutor example. First you read this question. In a school, 21 students of class 8 are randomly divided in 3 equal groups for comparative study of their span of immediate memory in 3 different motivational conditions. Condition A of 0 motivation, condition B of low motivation, and condition C of high motivation. The result obtained from all 3 conditions are given below. Here the results obtained from condition A is given to us, condition B is also given to us, condition C is also given to us. Now what we have to find, the first of all we have to find out is their significance difference between condition A and B. Second thing we have to find out is their significance difference between condition B and C. And the third one and the final thing is their significance difference between condition A and C. Test the hypothesis at 5% and 1% significance level. So how we solve this? So first we make 3 big columns here, the condition A, column 1, condition B and condition C. Then we divide each column into sub columns, one for x1 and the second for x1 square. Here also x2 and x2 square, x3 and x3 square. So here the condition A value is given to us 6579654 is given to us in our question. 6579654 is given to us. We have to write down similarly we have to write down the condition B value here for x2 and the condition C for x3. We will write in this way. Now what we do, we will make the square of this all. First we make the square of this all. So the square of 6 is 36, square of 5 is 25, square of 7 is 49, square of 9 is 81, square of 6 is 36, square of 5 is 25, square of 4 is 16. So we have to write down the square of this. Square of these also, 7 square is 49, 8 square is 64, 10 64, 7 square is 49, 9 square is 81, 11 square is 121 and 6 square is 36. Here we see the square of condition C, which is 121, 100, 144, 81, 144, 13 square 169 and 100. Now we get the summation of this all. Now we get the summation of this all. The summation of x1 is 42, summation of x1 whole square is 268, summation of x2 is 56, summation of x2 square is 464, summation of x3 is 77, summation of x3 square is 859. So this we have got all the summations here of this table. Now we find the mean value of each condition. So here we find out the mean value. First we find out the mean value of x1. So we get here x1 bar is equal to summation of x bar over n. Summation of x1, look at here, it is 42, and the total number of observation in each group is 7. Look at here, 1 2 3 4 5 6 7. So we have the 7 observations here. So we write down here 7. 42 over 7, which is 6. 7 6 times 42. Now x2 bar, which is summation of x2 over n. Summation of x2 is 56. We have over 7. 7 8 times 56. We get here. And x3 bar, which is summation of x3 over n. Summation of x3 is 77. We have, and divided by 7, which is 11. So we have got the mean values of all the groups here, 6 8 and 11. Now the second step, we have to compute the sum of squares. Now we have to compute sum of squares. So I explain how we will compute this. So first we compute SS1. We compute SS1, which is equal to sigma x1 square minus sigma x1 whole square over n. So we get here sigma x1 square, look at here, which is 268 we have. So we will write here 268 minus sigma x1, look at here 42. So we write down here 42 square, and the total number of data in each column, observation in each column, is 7. So we write here 7. So we simplify this. 268, if we take the square of 42, it would be 1764 and divided by 7. Here we get 268 minus 1764. If we divide by 7, we get here 252, and finally we get here 16. So this 16 we have got here. So this is our SS1. Now we find out SS2. SS2 is equal to sigma x2 square minus sigma x2 whole square over n. So here we write sigma x2 square. So sigma of x2 square here is 464. So we have to write here 464. 464 minus sigma x2. So here look at here, sigma x2 is 56 we have. So we will write down here 56 square over 7. So now we get here 464 minus the square of 56 is 3136 over 7. I get here 464 minus 448. If we divide 3136 by 7, we get 448, and finally we get here 16. So we have got here 16 SS2. Now we look at SS3. So SS3 is equal to summation of x3 square minus summation of x3 whole square over n. So here summation of x3 square, look at here, which is 859. So we have to write down here 859 minus summation of x3. So summation of x3 is here, look at here 77 we have. So we write down here 77 square over 7. So we get here 859 minus the square of 77 is 5929 divided by 7. Finally we get here 859 minus, if we divide 5929 by 7, we get here 847, and the difference of 859 and 847 here 12. So these we have got SS3. Now we have got all SS1, SS2 and SS3. Now we find next step. Now we have to find out the standard error. We have to compute the standard error. We know the formula for standard error, AC. I have explained you earlier. That is the square root of summation of sum of squares over number of group, and n is the number of observation in each group. We have to put down in this formula. So I write down first this formula here. AC is equal to square root of summation of SS over k into n minus 1. So I put down the values here. AC is equal to summation of SS. So we know that the SS we have got here, SS1, SS2, SS3, we have to put down these all 16 plus 16 plus 12. Plus 16 plus 12. Number of groups, we know that there are 3 groups ABC. 3 we have to write down. N is the number of observation in each group, which is 7. 7 minus 1. So we get here AC square root of 44 over 3 into 6, 18. So we get here square root of 44 over 18. If we simplify this, we get square root of 2.44, which is equal to 1.56. If we divide 44 by 18, we get 2.44, and we find out the square root of 2.44, we get 1.59. So this we have got the standard error, AC. Now we have to find the degree of freedom. Degree of freedom which is V. So V, degree of freedom, is equal to n minus k. N is the capital N is the total number of observations, which is 21. Okay. So put down here 21, and the number of group k is the number of group, which is 3. So we get here 18 is degree of freedom. So this is our degree of freedom we have got here, and we have to find out the least significant standardized range RP, which we get through the table. According to table, we get this. So through the table we could easily find out for number of groups, the number of groups we could write down here, the number of groups, 2 number of groups. Number of groups, I am writing down here 2 groups and 3 groups, and at 5% here 0.05, 0.0. At 5%, if we find out the value, we find here through the table 2.97 for two groups. 2.97, and at 1% we get 4.07. 4.07. Here for three groups, if we find it out, so we get at 5% it is 3.12, the book value for the table value, and for 1%, at 1% it is 4.27. So this we have got through the table the values at the 5% and 1% of 2 and 3 groups. This is the significant standardized range we have got here, list significant standardized range. Now then step 6, which is the compute RP. We have to compute the RP, and we know that the formula for this RP, I explain you again. Look at vision of this formula. RP here is equal to AC RP square root of 1 over n. So I write down first formula here. RP is equal to AC into RP square root of 1 over n. Here we found RP for two groups, 8, 5%, least significant level. So therefore this RP standard error, we see we have found out the standard error, which is 1.59. Now the RP, which is a standard error, we will put down here, which is 1.56. It would be common in all RPs, and RP, we see here the table value what we have got here, the table values we have got here, just a moment, is the table value for two groups at 5%, 2.97 we have to put down here, 2.97. And now root 1 by 7, so we calculate here root 1 over 7, which is equal to 0.378. So we will write it down here, 0.378. This would be common in all the RPs. So this figure 1.56 and 0.378 we have to take in all the observations common, and this would be changed according to the level of significance at the 5% or 1%, or according to the group, 2 group or 3 group. So it is for 2 groups we are taking this. So we get here, finally we get here 1.75. 1.75. This is the RP for within 2 group at 5%. Okay, at 5%. Now we see RP for two groups, 8, 1%. 8, 1%. So we see what happens now. It is Rp is equal to, we have to take this is 1.56, and at 1% for two group we see the value 1% for 4.07. we have to write down here 4.07 and 0.378. so we get here 4.07 and 3.378. sorry, so we get here finally 2.40. Now for three groups, Rp for three groups, we see at 5%. So we see what happens. Rp is equal to 1.56 would be same. For three groups at 5% we see 3.12. It is 3.12. So we have to write down here 3.12 and 0.378. So finally we get at 5% 1.84. Now Rp for three groups at 1%. So we get here Rp 1.56 into, we see at 1% for three groups we get 4.27. we get here 4.27 into 0.378 is equal to, at 1% it is 2.52. So we have got the RPs for 2 and 3 groups at different significant levels, 1% and 5%. Now arranging the mean of all groups in ascending order. As we have started the solution of this problem, first of all we have already found out the mean of all the groups. So we have to arrange the mean in ascending or descending order. I write down here A, B and C group. So we know the mean of A group is 6. Explaining well. So you have, it is 6, 8, 11. So we have to write down it as it is manner 6, 8, 11. The same way we have to write down 6, 8, 11. Here I write down the groups. And here the mean. Now we compare the difference of these means. If we find out the difference between A and B, so we get difference of A and B and B. So we get the difference here 8 minus 6, which is 2. 2 is the difference. Difference of B and C, we get here 11 minus 8, which is 3. And difference of A and C, which is 11 minus 6, which is 5. So Here we could now easily find out the differences 2, 3, 5 and the values of their respective values. We know that for two groups, here we compare with two groups at 1% and 5%. So I write down here 0.05% and 0.01%. We have the two values. For two groups we will write down here, and for two groups we have the value 1.75 and 2.40. 1.75 we have 1.75, 2.40. Here we compare again with 1.75 and 2.40. If we are taking the smallest and the largest one, the difference of the smallest and largest one, so we will apply for all three groups. It would be for all three groups. The difference of all three groups would be 5. So we have to compare with these values 1.84 and 2.52. So now we interpret the result. How we get the interpretation of this? This is for three groups, and see the smallest and the largest value. We are getting the difference of the smallest and the largest. It would be for all the three groups. This shows the comparison between. Here you see at 5%, if we see the A and B group, at 5% you see the 2 is greater than 1.75. So there is a significant difference between A and B. Okay, and at 1% there is no significant difference because 2 is smaller than 2.40. So here I interpret that. Now look at how to interpret this. So we have got all the values, all the mean difference we have 2, 3, 5. The mean difference we have for the group A and B is 2, B and C is 3, and A and C is 5. And at 5% we have got the RPs of all A and B is 1.75. The for two groups is 1.75, and for three groups A and C, if we take the smallest and the largest mean, the difference of the smallest and largest mean, it includes all the groups, all the three groups. We get the value here 1.84. Here for at 1% you see 2.40, 2.40 the same value here at 2.52. So it is we have got here. Now how we interpret this? So I explain you. If the mean difference of the groups is greater than the corresponding RPs, the mean difference is here, it is greater than the corresponding RPs. These are our RPs are here. So it is greater than the RPs corresponding, then there is significant difference. The difference is significant and our null hypothesis would be rejected. So here see at the 5% for A and B group, there is significant difference because the two mean difference is greater than 1.75. So our hypothesis is rejected at 5% for group A and B. But at 1%, look at here, the mean difference is only 2 here again, but at 1% the RP is 2.40, which is greater than 2. So our hypothesis is accepted here at 1%. So there is no significant difference here at 1% for A and B group, but at 5% there is significant difference. So for B and C we see here the mean difference is 3. At 5% the value of RP is 1.75 for at 5% for these for two groups B and C. So it is again 3 is greater than 1.75. So there is significant difference and our hypothesis is rejected. Here also 2.40 is less than 3. So it is also rejected at 1% for B and C. And here you see A and C. The mean difference is 5, which is greater than 1.84, which is the value of RP at 5%, and 2.52, which is the value of RP at 1%. So it is greater than both. So it is also rejected our hypothesis, these values, because the difference is significant as per this. So only at one place, at 1% for A and B, there is no significant difference. Okay, so accepted at only 1% for A and B, and the other all the parameters it has been rejected. So thank you.